Okay, it's 2:01. Welcome everybody to the ongoing Impact webinar series this fall. And as you're well aware, we hit a wide variety of topics on our webinars. And today we're blessed to have our friends from Simpson Strong Tie in the persons of Tim Ellis and Mike Lampley. I think particularly our steel erectors are going to get a great deal of information out of this and advantage hopefully in the marketplace. I'm Kevin Hilton. I'm the CEO of Impact, and thank you very much for tuning in. Before I turn it over to Tim and Mike, I just want to hit a couple of housekeeping items. As has always been the case, down at the lower part of your screen, we monitor the Q&A button, and we welcome any and all questions you have, but we just want to make sure that if you have something to say, you've got a question, comment, or concern, put it in the Q&A box because we don't monitor the chat. And we're going to get to any and all of your questions either online or post event. I would be remiss if I didn't invite you all to see our friends at Simpson Strong Tie in person. February 12th through the 14th at the Hilton in New Orleans at the base of Poitras Avenue. And I'll tell you what, you're going to come there on the 12th and you're going to get registered and you're going to go to the greatest Super Bowl party you've ever been to in your life with all of your best friends. And you'll get to mingle with our friends at Simpson Strong Tie along with about 60 other display people in our exhibit hall, our fabulous display hall. And then exhibit hall, I meant to say. And then as you go through the conference, you'll also get to spend time with your closest loved ones on Valentine's Day, February 14th, which is the last day of the conference. So we have everything for everybody in New Orleans and our industry. It's always a premier event. And we look forward to a very informative webinar. So at this point, I'm going to turn it over to Tim Ellis and Mike Lampley of Simpson Strong Tie. Guys.
Thank you, Kevin. Thank you for that introduction. And we too can't wait for the Impact Conference. We always have a great time there when we go. So today we're going to talk about some trends in the industry and how we can get more steel through your shop and get buildings up erected more quickly. And, you know, that makes everybody happy. We all make more money the more work we get. And so Simpson Strong Tie is, we always have our pulse on the finger of, you know, where the industry is going as a whole in construction. I know that most of you probably think that, you know, what are the wood guys doing here? But, you know, we actually have divisions that address the full matrix of the construction industry, our structural steel being one of the newer ones. But in our research that we do, you know, we found that the industry is indeed moving towards more bolted solutions. You know, we kind of started out with rivets and went to welds, and now it's going back to bolts, and a lot of reasons for that that won't go into here. But mainly the advantages of the bolted solutions are, you know, it's a lot easier to erect, a lot easier to install. And, you know, I think a lot of you are aware that there's a growing shortage of trades, skilled trades, and mainly because, you know, for the last 20 years or 30 years, you know, going to trade school was discouraged. And, you know, I don't know why. I mean, I came up through the trades and it's a great way to make your career as far as I'm concerned. But the reality is that we have fewer tradespeople coming up as people my age are retiring. And so we need to find ways to continue to service the growing construction industry much more quickly with, I hate to say less skilled labor, but with a different labor pool. And then there's some things that are also emerging on the governmental side that we're all going to have to address, like it or not, is they're going to be requiring built-in resiliency, and that means fast recovery after a major event. People, you know, people sheltering in place while building repairs are happening. We were talking about New Orleans. That's a great example. All those people moved out in the Ninth Ward. Now that was a flood, not an earthquake. But, you know, that'll never be the same because that we basically had to destroy that built environment. And so FEMA right now is looking at ways to actually retrofit that built environment. And probably by 2030, there's going to be some mandates out there that's going to be really good for all of us, because all of these millions of standing buildings, especially public buildings, will have to be retrofit. And there's no better solution for retrofitting any type of building, I don't care what it's made out of, than steel. It's fast, it's strong, and there's a lot of ways to use steel to retrofit that built environment. And then the other trend that's coming out, especially in design build space, is adaptive use. If your lateral systems and your structural systems are bolted, it's a lot easier to go in there as architects change their minds like they love to do, and go in and unbolt things and bolt new things in to adapt the use of that structure. Right now we have, hundreds of empty office buildings because we all went home, not us, but the people that are lucky enough to be working at home, we have all these empty buildings. So we're gonna have to do something with those, depending on how it goes here in the next 10 years. And again, changing those buildings out, a lot of those are made with steel. So we're really in a good place right now in our industry, and Simpson's trying to come up with some solutions to help us meet those challenges. So along those lines, our whole philosophy in this structural steel space is 100% field bolted solutions, easy shop operations with 100% fillet welds. And we have 3 products on the market right now, or 2 that are on the market and 1 that's coming in January. Our Yield Link moment connection, that's what Mike's going to cover. We have a Yield Link brace connection, which is 100% bolted BRBF. That's really going to change the industry, and we launched that on January 18th. Maybe that's a future topic, Kevin. And then our edge tie system, which is a continuous extruded channel that is welded to either the outside steel beam or outrigger system, and the facade is infinitely adjustable because the brackets can slide back and forth. Also has a really cool integrated reusable guardrail system that can be flown up with the beams and then moved up to the upper floors. This guardrail system can actually remain in place while the facade work is being done, as it complies with OSHA. But today, we're going to talk about the Yield Link moment connection. We launched this with our Strong Frame product line in 2013. A lot of fabricators that used the Strong Frame realized how fast and easy this was, and they kind of came to us and said, hey, can I just buy the connection from you? So we listened, and now we offer this Yield Link connection to the structural steel industry, and Mike's going to go through how we do that, and I'm going to hand it over to Mike. We're in the same room, so I'm just going to hand him the headset. So here's Mike.
Great, thank you, everyone. So moment frames are used for seismic areas. They're used for high wind areas, and a lot of times they're just used for open programs. We see moment frames used across the United States in healthcare, where they want to have that open programmability and the future programmability. The job you're seeing here is a performing arts theater, just the entrance of a performance art theater, which the majority of the building is CMU, but when it comes to the entrance, they want that complete open program with that glass, and they're using the Yield Link moment connection there. I'm going to be going over the features and benefits and how we can save you time and money. And the first one we come to, this is a project out in Utah. We don't require any bottom flange bracing. The way the Yield Link works is there's a Yield Link on each end, top and bottom. So all the yielding takes place in the Yield Link itself. So we don't get the torsional buckling that all the other pre-qualified connections have. So right off the bat, we're going to save your shop and the field the bottom flange bracing. No bottom flange bracing to be welded or erected on site. The Yield Link moment connection acts like a structural fuse, just like you'd see in a fuse box or in your house. So now the engineer can go ahead and design a building with these structural fuses in them and know in a catastrophic event exactly where the yielding is going to take place. The bottom right-hand picture you see there, that's a finite element analysis model. You can see the blue is no damage, so the beam and column are remaining elastic. And as the lateral force is applied, you see the yielding take place just in the yield link. The picture off the left shows yield links that have come out of our test frame, so you could see and get an idea of what type of yielding takes place. The yield link itself is a combination of the 4 ideas you see on the right there. We wanted to have a very ductile connection, and from the RBS, we've taken the RBS, or the reduced beam section, but rather than reducing the beam, we're reducing our link itself, because again, we don't want to have any damage to the beam. We wanted it to be repairable. Again, so in a catastrophic event, all the yielding takes place in the yield link, and we can go ahead and just replace the yield link and get the building back up and serviceable for the owner and the tenant. We've taken constructability, we've incorporated a T-stub, and that T-stub is what is attached back to the column. With all the current yield links that we have, it's always 4 bolts per link, so there's just 4 bolts to attach one end of the beam back into the column. And then everything is designed around our modified shear tab, and that's really for reliability. Reliability in a catastrophic event, if the yield links need to be replaced, you don't even have to go in and shore up the beam. You can actually remove the links, put new links on, and not worry about shoring up the beam, because the shear tab will go ahead and handle the load there. We are a pre-qualified special moment and intermediate moment frame connection. So we're in AISC 358. We have our own chapter, chapter 12. We also simultaneously run an ICC report, because it takes about 3 or 4 years to get information into 358. Every year we come out with an ICC report that is going to go ahead and allow us to get new information out to the structural engineering community. In our current ICC report, we have information that I'll go over in a second on our cruciform columns. For those of you that are doing work out in California, we are HCI approved, which is the new name for OSHPD, and DSA approved, so we can be used in California hospitals and California schools. This is a test video, so not only do you have to do the finite element analysis modeling, but you also have to do full-scale cyclic testing. So here you can see a test frame. We're using 21.5 foot columns, and we're doing a 35-foot unbraced length on the beam. So as that lateral force is applied, you can see we're getting no buckling in the beam. The upper right-hand picture gives you an idea of what that modified shear tab looks like. So everything's rotating around the center hole there in the vertical stack of bolts. All the other bolts are horizontally slotted, so that joint will move. And then the axial load bolts, the 3 bolts off to the left, I'll handle the axial load from the beam back into the column. Once we complete that right there, 4% drift, that allows us to become a pre-qualified connection with a lot of other information. But one other thing the CPRP panel wants us to do is take it out to failure. So if you look at that bottom length, we take it out to 5% drift, and we'll get a failure in the bottom link. Again, that's double the allowable limit, and that's probably, even in a catastrophic event, you would probably not see that type of failure. You would have yielding in the link, but not that type of failure. So 4 years ago when we completed that test, this information can be found in supplement 1 and 2, was released in July 2020. So we're fully tested up to W36-inch beams, any weight per foot. Again, the seismic beam bracing is not required. Another thing that has solved a lot of issues for the engineering community is tall, slender moment frames. We do not have a beam to span ratio. All the other connections that are pre-qualified have a span to depth ratio. So if you have, say, a 24-inch beam, the minimum beam length is 14 foot. We don't have that span to beam depth ratio because we look at the maximum probable moment of the link and not the beam. So it allows us to do taller, narrower moment frames. We're also fully tested in columns up to, for W36 up to any weight per foot. And our yield link, we've tested up to 1 inch thick and 6 inches across the yielding dimension, which I'll show you in a second here. This is the table. This shows our current links that we have available. Simpson likes our nomenclature, so off to the left you can see the nomenclature there. So YL stands for yield link. The first number is the thickness of the stem. That's the thickness here. And they're in eighths, so a YL4 is 4/8 or ½ inch. You can see we have 3/4 inch links and 1 inch links. And then the last number is the B yield dimension, and this is the cross section of yielding that the engineers use to go ahead and design, and gives them an idea how stiff the connection can be. In the table here, we have it broken up in 4s, 6s, and 8s. So the YL4s are good for W12s to W18. The YL6s are good for W16 up to W27. And then the YL8s are good for W24 up to W36. We have added a second dimension, and these links here highlighted in red are used for built-up shapes. You can see the 4s, we have the -10, the 6s, the -13, and the 8s, the -15. And this allows us to use lighter built-up shapes for our metal building manufacturers and those doing built-up shapes. With these new links here, we're able to do built-up shapes up to 44.5 inches. The yield links here, the three pictures here, all the yield links are manufactured in our Riverside plant, and all of these yield links are on the shelf items. So you can order these, we package them up and send them out, and we keep a sizable inventory. The manufacturing process is we'll take a wide flange beam that meets the T-stub requirements and the web requirements for the stem. We'll drill all the holes, then we send it through our plasma cutter, cuts it out. We knock them out, clean them up, paint them, and get them ready to ship. One thing for the fabricators and erectors to note, you can see how they're packaged in pairs. One of our requirements in our chapter in 358 is we have to match heat numbers. So we will ship them to you in pairs, and that pair needs to be put on one side of the moment beam. So that's how we ship them, and that's why we ship them like that. We go to market with these. We sell them in kits, and a kit is for one side of the moment beam. The kit includes a yield link top and bottom, the 2 spacers top, 2 spacers bottom, and then the buckling restraint plate top and bottom. The beams, the columns, the stiffener plates, the shear tab, nuts, bolts, and washers are all provided by the fabricator or erector. One other thing to point out, there's no field welding, it's all bolted. The only shop welding that's required is on the shear tab and the stiffeners, and all of that can be fillet weld. Even the welds on the stiffener plates into the column flange are all fillet welds. We've done all our testing and everything, and all we require is fillet welds in the shop. So that's going to eliminate all your CJP and PJP welds and all your ultrasonic testing. When it comes to detailing, it's going to be the easiest connection you've ever detailed, even if you've never used a connection before. We have free plugins that we give to Tekla and SDS2 users. This is simply going to take our nomenclature off our plans and plug it in, and the joint will go ahead and detail the location of the bolts, bolt size, and slots needed. We also offer a free courtesy check on shop drawings. So along with sending those shop drawings to the EOR, you can send them to us, and we will go ahead and make sure that all the bolt holes are in the right location, sizes, and everything checks out, and we'll get that back to you. Usually that takes place in 24 to 48 hours. Another key point is, I know there's other proprietary connections out. We're different in the fact that we charge 0 licensing fee. So we don't charge any fee to the design team, and there's no fee to the fabricator or the erector. So no licensing fee, and there's no minimum square footage. We'll do a simple single bay, single level frame and a retrofit all the way up to a 6-story, 1 million square foot building. Any size job, no licensing fee whatsoever. When the engineer goes ahead and designs with the structural analysis software, at the end, we give them an option to print a DXF file. The DFX file will print an elevation drawings of the elevation drawing of the moment frames. The small box here will give you a takeoff of the yield links required for this frame and all the welding information there. Here's a little blow up of what that looks like. So there's a lot of nomenclature there. First to point out, the yield links used on this joint is a YL6-3.5. Next is the shear tab. Shear tab is a STP4. Again, this is 4/8, so this is a 1/2 inch shear tab. And then the, a 1/2 inch stiffener plate. And then on the shear tab, ST4, this is a 1/2 inch shear tab. Then we move to -7. 7 lets you know that it's 7/8 bolts. And then A is the grade of bolt. So if you come over here and you look at A is going to simply be an A325N bolt. And then the -2 is the number of axial load bolts here. So again, you have the one round hole, and then this hole will be a vertically slotted hole. So we'll go over bolting a little bit. First thing, we require the fewest amount of pretension bolts. The only bolts that need to be pretension are the bolts that go from the link stem into the bottom and top flange of the beam. We give the option to the erector. They can do turn a nut, they can use a tension indication washer, or they can use a TC bolt, whichever they choose. For the buckling plate, those bolts are required to be snug tight only. Again, the buckling plate, since it's a TC couple, it works in tension and compression. In compression, we don't want that link coming off the beam. So we put the buckling plate in place to keep that link against the beam. And again, we don't want to develop any extra friction, so those are snug tight bolts. From there, the balance of the bolts that go from the T-stub into the column and the shear tab, those can all be either snug tight or pretension, whichever you choose. If you want to use TC bolts, you can pretension them. If you want to do standard bolts, they can just be snug tight. The sequencing for erection, again, is to go ahead and erect with a center round bolt in the shear tab first. Then you'll go ahead and maybe take the upper left bolt from the T-stub back into the column, and then take the lower right. Once you get those 3 bolts in, you now have the beam secured, and you have the beam plumb, and you can release the crane and then stuff and snug the balance of the bolts. Another thing to point out is, unlike all the other connections that are pre-qualified, we have a much smaller protected zone. So our protected zone is 1 inch off the beam, or 1 inch off the bolts into the beam, and 2 inches off the shear tab, which leaves all this room in here that you can cut, punch, or bring other beams in. In the picture here, you can see this is a W30 beam with another W30 beam coming in. And with all the other moment connections that are pre-qualified, you can't do this because this would be the protected zone. So again, this solves another issue. Sometimes you have elevators, stairs, or you just need a beam. This isn't a steel podium for low-income housing. Sometimes you need to go ahead and run a beam in there, and with our system, you can go ahead and do that. Talked a little bit about resiliency and how these links can be repaired. A question that comes up, well, how do we repair it if we're doing metal deck and concrete on metal deck? We sell a cover plate that will go ahead and cover up the link. We also require 1 inch compressible material. That's just your standard foam to be against the concrete, from between the concrete and the column. That'll allow the joint to move. And then we have our right angles, and these are our deck support. From there, we'll go ahead and finish it up with right angles and our bent plate around there. So if we have a catastrophic event, typically the yielding takes place in the bottom link. If the bottom link needs to be replaced, the top one needs to be too. So you're going to need to go ahead and just chip out a little bit of concrete there, expose that cover plate, pull that out, that'll expose the link. Pull the link out, you can drop a new one in there, and then repeat the process with a cover plate and the compressible material, fill it back up in concrete, and replace the bottom link, and then now that joint has been repaired. Not saying it's easy, but it's much easier than trying to replace a beam in one of these projects. And here you can see, so this is the deck support straight. This is on the outside of the wall. And then the deck support at an angle. We always recommend the angle because they're always, all the other MEP trades are always trying to drop pipes and drain pipes and different stuff down as close to that column as possible. And by going with an angled deck support, it just leaves that room to go ahead and do that. Here gives you a good idea of that modified shear tab that we've talked about. Again, the center hole is the one round hole. All the other holes are vertically slotted. And then the axial load bolts, we can do 1 to 4. And again, it uses that center round hole, and all the rest of the holes are vertically slotted. In the table on the detail sheet, we'll go ahead and give you the number of vertical bolts you can use per connection, but we also give the engineer the option to do 7/8 bolts all the way up to 1 1/4 and A325 up to A490. And here you can see a beam installed out there. We oversize the top holes for the top link to give us some adjustment, and then the bottom holes are vertically slotted to give you some adjustment for different size beams. And then on our YLINST sheet, again, after the elevation, all these detail sheets print out, we give you all the dimensions. So if you're not using Tekla or SDS2, we can provide these sheets so you can go ahead and do your drawings in CAD, and this will give you all the dimensions for all the bolt locations, sizes. Cruciform columns. This is the Valley Children's Hospital in Madera, California. Here we're showing off our cruciform columns. A couple things to point out. It can be used in a corner condition, can be used in the end of wall condition like you see here, and then a true biaxial moment connection where you have 4 beams coming in. Again, one thing to point out, the WTs welded to the web is just a fillet weld. And again, the stiffeners are just a fillet weld. So we're going to save you about 75% of welding there. And also we're going to get rid of all that UT inspection. So save you a lot of time in the shop. We can slope the beams. The beams can slope up to 1 inch per foot for water runoff. This is achieved by putting in a shim. One thing to point out though, we talked about these bolts being snug tight. When you do slope the beam, they will need to be pre-tensioned. So the bolts, if it's being sloped, they need to be pre-tensioned. If the if the beam is parallel, then you can just use snug tight bolts. So in conclusion, the yield link moment connection is a pre-qualified, intermediate, and special moment frame connection. Again, and also can be used anywhere where you need a large opening and you need a lateral system with no bracing or shear walls. It's a fully field bolted solution with no field welding. The only welding that takes place is fillet welds in the shop. Since it's fillet welds, there's no UT inspection. In fact, the only special inspection, if you're using it for an R value of 8, as a special moment frame connection, is the visual inspection on the bolts, again, that go from the yield link stem into the beam. Can be designed without bottom flange bracing. There are some cases, if we're doing some 60 or 70 foot moment frames, to reduce the size of the beam, they'll put in maybe 2 or 3 braces. That's up to the engineer, but we do not require bottom flange bracing. And then we talked about it being a replaceable structural fuse. Again, for more resilient structures, in a catastrophic event, you could go back in and repair it and get it back up and serviceable. You can go to strongtie.com/yield link for all our design tools. Again, the plugins for SDS2 and Tekla are free. The support is also free too. So if you get into that, you have a hard time downloading it, or if the detailer has questions, they can always contact us. All the tools and all the support is free. And then again, unlike other proprietary connections, we have 0 licensing fee. There's no fee to the design team, there's no fee to the fabricator, there's no fee to the erector, and there's no minimum square foot. Like I said, if you just need one moment frame and a retrofit, we'd be happy to help you out and provide that for you. So just some additional resources there. Again, you can see more at strongtie.com/yield link. That's where you can find our design tools. You click on this link and you can find the link to the Techland SDS2 plugin. Also our contact information if you have any other questions. If you're interested in us having us in on a job site or for a presentation at your location, we'd be happy to fly out and take care of that. And then also we have a flyer and a connection design guide that you can get PDF copies off the website, but you can also contact us and we can send hard copies out to you as well. So with that, I'm going to go ahead and turn it back over to Tim, and we're going to see if we have some questions. And thank you very much.
Right. Well, Tim
Great
and
job.
Mike, thank you very, very much for the highly informative webinar. Again, you can meet our friends at Simpson Strong Tie at our conference in the exhibit hall. The exhibit hall kickoff on the morning of Sunday, February 12th, Super Bowl Sunday. And the exhibit hall will be open all day and then much of the morning, the following Monday. So we look forward to seeing you in New Orleans in the middle of February. And Tim and Mike can't thank you enough.
Yes, thank you very much.
Very well done. This whole presentation, oh, you're more than welcome. This whole presentation, along with the slides, will be loaded onto our website early Monday morning. And we do have one question that came in. We've got time for one quick one. Does Simpson do design for calcs? Let's see what this says here. Does Simpson do the connection design with calcs for, it's cut off on here for some strange reason.
So I think they're asking if we do the connection design. So we have tools that we give to the designers for free, and we also do free support for that. So it, doesn't matter the level of engagement of engineering and design support. We offer that all for free. But we will only be looking at the connection design itself. We don't go beyond that. We don't presume to know the other loading on the building. So, but we're in all the major design softwares: Risa, SAP 2000, RAM, ETABS, and then we also have our own design software, and all of that's downloadable for free on our website.
Great. Well, come and see these people in person in New Orleans, and look forward to this being up on the website. And again, Tim, Mike, thanks so much. Thanks to all our people at our good friends at Simpson Strong Tie. We'll see you in a couple of months.
Thank you very much, everybody. Stay safe out there.
Take care. Bye-bye.